Sir, class is started. No audio, sir. Anybody, please?
Not yet started, Andy. Just wait, please. Technical issues I'm solving in the background. Okay.
Thank you so much, sir.
Yeah, good morning all. Let's start the class.
Morning, sir.
Let's start the
Morning,
class.
sir.
Yeah, okay. Is my voice is audible to you?
Yes,
Yes,
sir, it's
sir.
clear.
Okay, thank you. Yeah. But before going to alkylite, a small topic is remained in the terpenes and terpenoids, right? Then first I'm stopping the sharing of the slides. Then again I'm going to share in OneNote. Yeah. A continuation to the terpenoids and terpenes and terpenoids. That is only one topic is left in this topic. That is biogenesis of monoterpenes. Monoterpenoids, biogenesis of monoterpenoids. Now, what is biogenesis? What is biogenesis? Is there any definition you know? You tell me. What is biogenesis? Anyone can reply, please. If you know, please reply. Yes. Investigation of path of biosynthesis of a natural product is known as biogenesis. That is, we are finding out the pathway of the synthesis of the natural products. How the product is naturally synthesized. That pathway is we are going to find out. That process is known as biogenesis. Right. Now here we are going to synthesize terpenoids or monoterpenoid, especially now. Terpenoids are acetogenesis or acetogenins. Acetogenins means these are synthesized from the acetic acid. The biosynthesis initiated by acetic acid is initiated by the acetic acid. Now here we are going to discuss here the biogenesis of monoterpenoids. Then monoterpenoids are biosynthesized by acetate pathway. Acetate pathway means it starts with acetic acid. Acetate pathway via right. This acetate pathway is the starting point. That is, the acetic acid is the starting point. This acetate pathway proceeds through via the formation of malonic acid intermediate, a key intermediate, via the formation of malonic acid that is indicated with the MVA. malonic acid intermediate. Now, every step of this biosynthesis, every step of the biosynthesis is catalyzed by an enzyme. Okay. Now, coming to the synthesis, it starts with acetic acid. Then it is react with a coenzyme S-CoA. Yes. Then it leads to formation of acetyl CoA. That is the coenzyme. This is called acetyl CoA. This acetyl CoA again react with another molecule of acetic acid. Leads the formation of S2-acetyl S-CoA. This is the S2-acetyl. S2-acetyl S-CoA. Again, this intermediate. This is named as acetyl S2-acetyl. S2-acetyl S-CoA, which is further reacting with another molecule of acetyl CoA. That leads to the formation of a malonic acid S-CoA. This is the malonic acid. OH. S-CoA. And in which OH. So its name is malonic acid. S-CoA. Now it is reacting with nicotinamide diphosphate hydrogen NADPH. NADPH. Then it leads to the formation of a reduced product, that is this carboxylic acid COOH is reduced to alcohol, that is the carboxylic acid is converting into alcohol. Then the remaining part is as it is. No, right. Here, this one is also reduced actually. Okay. One of the carboxylic acid is converting into alcohol, and SCOA is converting into corresponding alcohol. And one of them is converting into carboxylic acid. This is R malonic acid. This is malonic acid SCOA. It is complete a molecular malonic acid. It is the coenzyme, malonic acid coenzyme. It is the full molecule. Now it is undergoing decarboxylation followed by dehydration. How it is undergoing dehydration? We get here. A lone pair of electrons is donated to this one. Now this bond will be donated. This bond pair of donated to here, and this OH is eliminated as OH. Now from hydrogen, this OH will be lived as H2O, and this fragment is lived as CO. Now it leads to the formation of like right. OH. This is the compound. This can be also written as like this. One, two, three, four, five. 1, 2, 3, sorry, 1, 2, 3, 4, 5, right? Now this is the double bond. Now further it is treated to phosphorylation. That is treated with ATP. Is known as phosphorylation. Now it leads to the formation of this OH is attached with the phosphate esters. Then it leads to the formation of the product is like this. It is the diphosphate derivative. Now it is undergoing isomerization. Is undergoing isomerization. How it is undergoing isomerization? This beta hydrogen pair of electrons are donated here. Now this pair of electrons are donated here. That is, we can do 1, 1, 2, 3. Now this is called 1,3 shift. 1,3 shift reaction. Now it leads to the formation of the product is now it is dimethyl allyl pyrophosphate. The product is dimethyl allyl pyrophosphate. Now this is the key intermediate to generate the product. The two molecules of this pyrophosphate, dimethyl pyrophosphate, another molecule of pyrophosphate. That is the first one is the isomerized product. The second one is the non-isomerized product. Right. Now, during the isomerization of the second product, these 5 electrons are donated to this position. Right. At the same time, this carbon-oxygen bond pair of electrons are moving to this oxygen. Now it leads to the formation of the extended structure. Extended structure. Okay, this is the product. What is the name of this product is geranyl phosphate, pyrophosphate. Geranyl pyrophosphate. This geranyl phosphate it is a straight chain. I am rearranging to this in the cyclic nature of, even though it is a cyclic compound, I am rearranging the structure like this. Each P is indicating one phosphate. This is indicating with one P, this is indicating with another P. Therefore, this is OPP. Now it is an important intermediate to convert the cyclic terpenoids. Cyclic terpenoid. First, you take the path 1. In this path 1, just simply these 5 electrons are donated here. The OPP is eliminated as leaving group. Right? Then it leads to the cyclic structure. This is the cyclic structure. Right. Now it is undergoing, whenever it is donating, this one is, it is the actually, yeah, it is generating a positive charge here, plus charge. This plus charge is eliminated by donating this 5 electron to this position. Now it leads to the formation of another intermediate. Now again it gains a positive charge here. Now, by simple hydroxynase an enzyme that leads to attaching of one hydroxy group. One of the hydroxy group is here. Now, another enzyme, oxidase, that hydroxy group is converting into corresponding right. This is the camphor, biosynthesis of camphor. Now another pathway 2. Formation of the same intermediate, cyclic intermediate. Plus charge. Now it is reacting with the hydroxynase. Then it leads to the formation of alpha terpineol. And another one. It leads to the formation of, there is a hydrogen. This bond pair is donated to here. Then it leads to the formation of What is this? Limonene. This is the biosynthesis of monoterpenoids. Now the biosynthesis starts from the acetic acid through the formation of acetyl malonic acid. That is, first it is converted into acetyl CoA. The acetyl CoA is converting into malonic Ka. The malonic Ka is undergoes phosphorylation. That leads to the formation of dimethyl allyl pyrophosphate. This dimethyl pyrophosphate and its isomeric structure undergoes the reaction, condensation reaction, that leads to the formation of geranyl pyrophosphate. This geranyl pyrophosphate is undergoing cyclization by the leaving of two biphosphate leaving group. Then it leads to the formation of alpha terpinol, limonone, and camphor are the products. Okay, this is about the structural elucidation and biosynthesis and structural discussion of the terpenes and terpenoids. Now coming to alkaloids. Coming to alkaloids. Can I stop the share of this note file? One note. Yeah, I'm entering into the presentation. Now coming to alkaloids. Now alkaloids. Alkaloids are also the natural products which are isolated from the nature. Then the first, the word alkaloid. The word alkaloid means alkali in nature. Alkali in nature. These are the organic compounds, are also called organic bases. Organic bases. According to Meissner, the scientist named Meissner, approximately in 1890, he suggested that all the organic bases, according to him, all the organic bases isolated from nature are known as alkaloids. Are known as alkaloids. Therefore, according to the Meissner, all organic bases isolated from, especially plants, isolated from plants or nature, is isolated from plants are known as organic bases. Whenever we are isolating these compounds from plants, the alkaloids must have nitrogen is the one of the elements. Nitrogen element is present in that molecule. That is, according to Meissner, all organic bases isolated from plants which contains the nitrogen is the one of the element along with carbon, hydrogen, and oxygen are named as alkaloids. Alkaloids are natural plant compounds having basic character. Basic character means alkali in nature, basic in nature. Basic character and containing at least one nitrogen in its cyclic system, heterocyclic system. Right. Next one, another scientist came, that is Mayer. Name is Mayer. MEER, sorry. MEYER, Mayer. In 1896, he proposed that alkalides are the basic compounds isolated from plants and are frequently distinguished by their physiological activity. So many compounds, so many natural products are isolated from the plants. Okay, so many compounds, natural products are isolated from the plants, which are differentiated by the different physiological activities, are named as alkalides. Are named as alkalides. Therefore, they contain carbon, nitrogen, hydrogen, and in some cases oxygen with respect to their structural resemblance. Then these are having the alkali in nature. Due to that reason, all the organic compounds isolated from the plants or any natural sources, which having in basic in nature, are known as alkalides. Are known as alkalides. Now, these alkalides, example for the alkalides. So these are the sources. Example for the alkalides. We have several examples which are isolated from the nature. Right. Nicotine. This is the nicotine structure. This is a pyridine derivative. This is having the nitrogen. At that you find that pyrrole is substituted at the third position of pyridine. That is N-methyl pyrrole. N-methyl pyrrole. This is called nicotine. It's called nicotine. And another one, ephedrine. I have already given these examples: ephedrine, morphine, quinine, piperine. All these factors are given at the introduction of the natural products. Okay, we can take those factors from that. Okay, now test for the detection of alkali. Test for detection of alkalides. These alkalides can be detected by using two tests. One is the Mayer test. Mayer's test. Right. And the second one is drag and drop test. Second test is drag and drop. Test. These are the two tests. In the first one, Mayer's test, we take the Mayer test. In that, the reagent is prepared with the potassium iodide and mercury chloride, HCl2 solution. Whenever we are mixing it with the alkaloid, whenever it is mixing with the alkaloid, it leads to the formation of yellow cloudy precipitate. Yellow precipitate. Then it is indicating the positive test for alkaloid. Positive test for alkaline. Right. Coming to the drag and drop test, it is the bismuth derivative, bismuth nitrate is used. Bismuth nitrate plus potassium iodide. These are the two mixtures. Bismuth nitrate plus potassium iodide. This is the mixture used for the alkali test. When the solution contains alkali, whenever we are adding this solution, then it leads to the formation of white colored crystal. White crystal. Therefore, these two tests are very easy steps to determine the presence of the alkali in the solution. Just a minute. Okay, these two tests are helpful for the finding out the presence of alkali in the plant material. Okay, next isolation of alkali. General method, general extraction methods. Methods of extraction of extraction or isolation of alkali.
Sir, we didn't get any matter on the slides.
You didn't get any matter?
Yes, sir.
Just tell me. Now it is showing. Is it showing?
Yes, sir.
Yes, sir.
Okay, okay. Now the methods of extraction or isolation of alkalis. There are three methods. The first method is method 1. In this isolation or extraction of an alkaloid by treating the plant material with alcohols like methanol and ethanol. That is, alkaloid may be extracted or isolated by treating the plant material using organic solvents, that is polar organic solvents like methanol or ethanol, isopropyl alcohol, like that. Okay, what's happening? This is the plant material. You are collected with the plant material. This is the plant material, right? It is a powder for plant material. It is a powder plant material. Just add the alcohol in a, all this thing is taken into the a round bottle flask, carpet flask. Then just boil it for some time, that is in the prescribed time. Later, filter it. Then you can filtrate and residue and filtrate. Just filtrate, evaporate the solvent, you will get the residue again. Then this residue on treated the separation. Separation by using the chromatographic method or any other recrystallization method, fractional distillation, fractional crystallization. We can use those methods, we can separate. This is the method 1. And then method 2. When method 1 is used, the alkaloid compound is unable to soluble in the alcohol. Then the second method, just a minute. Have you noted down it? Yes. Okay. Method 2. Just a minute. The slide show, this is the problem. Every time you need to erase. Or we can also take the other slide also, but please need to exit the sharing the slide. Okay. Next, method 2. in this method, you know that the alkaloid is in basic in nature. Okay, these basic compounds ultimately soluble in acidic solution. Ultimately soluble in acidic solution, right? These acidic solutions can be neutralized after extraction of the plant material with the acidic solution, as acid solution. Then separate that acid solution from the plant material. Then simply neutralize it. Then a precipitate is generated. Precipitate or liquid oil compound will be generated. Then it is again extracted from the by using the organic solvent. We can separate. This is the second method. Take the plant material. Just add acids, that is dilute acids. Actually, we are going to use dilute acids. Dilute acids like dilute HCl, dilute H2SO4, organic acids also, tartaric acid, like that. These acid solutions are added to the plant material. Here always you need to take the plant material well fine powder form of natural source. Then this will be stirred for some time, prescribed time, right? Later filter it. Under filtration, we'll get the plant residue. And filtrate. Then filtrate is neutralized with exact neutralization. Neutralize it with ammonia solution or sodium hydroxide, any base solution, or sodium carbonate solution, that is the alkali solution. Then it leads to the formation of a crude product in the form of oil or a solid. Then verify that whether it is the mixture of alkalides, a pure product, or some more mixture of 3 or 4 compounds. Once it is the pure compound, directly we can use it for our observations. Or if it is a mixture of compound, you need to separate by using the separation methods like chromatographic methods, crystallizations, distillations, fraction crystallization, recrystallization. All these methods can be helped. Next, third one. The third method is method 3. It is the simplest method. Method 3. Directly take the plant material. Then it is boil with the, not boiling with, just add and stir with the ammonia solution, dilute ammonia or ammonium hydroxide solution. Then again you will get the material, just filter it. Again you will get the residue and filtrate. Just filtrate can just neutralize it. If it is required neutralization, neutralize it. Then we'll get the alcohol. Now this is the 3 methods. These 3 methods can be shown in a single flowchart method. I will show that flowchart method. Just a minute. Yes. Screen is visible to you?
Yes, sir.
Yeah, now see that the extraction flowchart, extraction isolation of alkylides. Extraction and isolation of alkylides. First, take the plant material. Yeah. This plant material should be, this plant material may be roots, seeds, leaves, or bark. Is anything. Right? You should powder it first. Fine powder. Make into fine powder. After preparation of fine powder, the first method is the method 1. Previously, I have explained the method 1. You should extract it with methanol or ethanol or any alcohol. Sometimes methanol, ethanol polarity may not sufficient. Some polarity may be higher than the required solvent nature. In that case, we need to decrease the polarity. In that case, we are going to use butanol, isopropyl alcohol, like solvents. Okay. Then it leads to give the methanol extract. This methanol extract later distill the methanol. Then you'll get extract crude material. Extract crude material. Then again dissolve it in dilute HCl or H2SO. Then the base material, is there any alkaline material is present in this extract? Is there any alkaline material present in this extract will be dissolved in this dilute acid. Therefore, a base extracted, bases are extracted. Bases are extracted as their water soluble. As their water soluble salts. Suppose, for example, a pyridine derivative is there. For example, a pyridine is there. Now, whenever you are adding dilute HCl, then it leads to the formation of an HCl derivative. Positive charge is there. This positive charge is stabilized by a salt. This will be dissolved in the water. This will be dissolved in the like way. The alkaloid is in the form of a primary, secondary, tertiary amine forms of nitrogen that will be reacted with the dilute acid. The dilute acid generates the salts. That salt will be dissolved in the water. Therefore, that will be extracted from the crude material, that crude material, right? Now that the crude material comes into the bases are extracted as their water soluble salts. Now, just filter it first. Filter it. We will get the filtrate. Residue is also obtained. Is there any insoluble material is there? Residue is also obtained. You leave the residue. Just collect the filtrate. From the filtrate, neutralize it. This filtrate is neutralize it. with any alkali solution. Alkali solution, that is sodium carbonate, sodium bicarbonate, sodium hydroxide or potassium hydroxide, right? Or liquor ammonia solution. Therefore, it will be neutralized if free bases of alkylates are generated. Free bases of alkylates are generated. These are the, suppose this free base of alkylate contains only one alkylate, just take it as the original product, or if it is a mixture of product, again you need to treat with the solvent extraction. You need to extract with the chloroform, ether, like that. Here you need to start with the, suppose it is the based on the polarity of the alkylate present in it. If the more polar and low polar two compounds are there, you need to use different polarity solvents, like by the increasing or decreasing. Suppose if you are using high polar solvent at a time, both the compounds are soluble in the solvent. Due to that reason, you need to start the low polar solvent first. Low polar solvent means hexane, benzene, and ether, chloroform, like ethyl acetate. In this way, you need to increase the polarity. Suppose the two compounds are there, one is the low polar compound and another one is the high polar compound. To separate the low polar compound, you need to use the low polar solvent like benzene or chloroform. If the high polar compound is there, you need to use the increase the polarity of the solvent like acetone, ethyl alcohol. Again, you need to use that. Okay, but the order of priority to separate the alkylates is first low polar solvent should be separated, then high polar solvent should be separated from the mixture. Okay, if only one compound is present in this pre-base mixture, then you can use it as it is. There is no need to separate them. But whenever the mixture is there, there is other extraction methods with these organic solvents using. You need to extract them from that mixture, right? This is the method one. In the method two, directly they take the plant material. This plant material in the method two, you should directly come to here. Why? You skip this one. You skip this one. Directly add dilute acids. Dilute acids like dilute HCl, dilute H2SO4 or H2SO4 or tartaric acid, like acid solutions are directly added to that. Then mix it, stir it for some time. All the alkaline compounds are dissolved in this acid solution. Directly get the bases are extracted as their water soluble salt. Remaining organic compounds will not soluble in the HCl and H2SO4, dilute H2SO4, because they are non-polar in nature. These acidic compounds, acid solutions are highly polar solvent. It can only dissolve the basic compound. Only bases are soluble from the plant material to the acid solution. All are come into this solution. Directly you came to this step. Again, you need to perform the next step. In the third one, some plant materials are soluble in the ammonia. Directly you can add ammonia. This is the method two. This is the method one. Sorry. This is the method one. This is the method two. This is the method three. In that, you need to add dilute ammonia, or it is ammonia. Okay, it is also called ammonium hydroxide solution. You can add ammonium hydroxide solution and stir it at the room temperature. Directly, you can take the free bases of alkalides are soluble in the ammonia solution. These ammonia solution will be extracted with the organic solvent. You can separate them as separate compound. Okay, this is the extraction method. Okay, next, classification of alkalides. classification of alkylates. Okay, in your syllabus only the alkylates classification based on the sources only. The first one, phenylethylamine. What is the type of functional group present in it? Based on the functional group, they are classified. That is phenyl. A detailed classification I will give you again, right? Phenyl ethyl amine group. This is the one type of alkylates. In that example for this, ephedrine. The structure of ephedrine is CH3. Okay, this is the ephedrine. In that you see that phenyl ethyl amine. Phenyl ethyl amine. This is the ethyl fragment. This is the ethyl fragment. And that ethyl, that is CH2, C carbon ethyl derivative is. At that N-methyl amino group is substituted. This is N-methyl amino group and phenyl group is substituted. N-methyl ethyl amine derivative. N-methyl amine, N-methyl phenyl ethylamine derivative. Okay. Now, second one, pyrrolidine group. Pyrrolidine group. Example for this, high green. This pyrrolidine group, you can also take the nicotine molecule also. Previously, I have given that nicotine. Okay. Pyrrolidine, the high green is the example for this. The structure of high green is NCH3, CH2, CO, CH. This is the keto group. CH2, CO, CH. This is high green. Next, pyridine and piperidine group. Third one, pyridine and piperidine. Pyridine and piperidine group. Example for this group is nicotine. Nicotine, piperine, cocaine. These are all the example. Example I am giving to you, cocaine is the example. C6H5, COO, CH3. And NC. Okay, this is the piperine group. Other examples are also there. Piperine, nicotine are also example for this type. Next.
Sir, page down, sir.
Down, sir, please.
Okay, sir.
Right. Next one is quinoline group. Fourth one, quinoline group. Quinoline group. In this group, example is quinine, cinchonine. Quinine and cinchonine. You know the structure of quinine I've already given in the starting of this class, starting of this chapter, right? And next one, isoquinoline group. Isoquinoline group. This isoquinoline group, papaverine is the example. These two all, quinine and papaverine are the compounds you need to structure determine. Papaverine, papaverine. The structure of papaverine is it contains the isoquinoline structure. This is the isoquinoline. This is the isoquinoline alkaloid, that is papaverine. Next to phenanthrene group, that is the morphine is the example for this. Sixth one, phenanthrene alkaloids. Example for this, morphine, codeine. These are the isomeric structure, codeine and morphine. Okay, you know the structure of morphine. Take this one, codeine. The structure of codeine, right? Now this is the phenanthrene alkaloid. Next, coming to seventh one, that is indole group. The best example for indole group is indolestic acid. Indolestic acid is also naturally occur material. Many of them, you know, a plant hormone. This is growth hormone. and several other molecules are also known. That is indole group alkylide, vinblastine, lysergic acid, reserpine, yohimbine, and indolestic acid. You know the structure of indolestic acid. This is indolestic acid. This is also an alkylide isolated from the plant material. Okay, this is about the classification of alkylide. Now coming to alkylide nomenclature. Alkylide nomenclature is assigned in different way based on the heterocyclic present in it. Based on that heterocyclic, we are giving the name of the compound, and also based on the sources. The source which is isolated, suppose papaver. The papaver is isolated from the papaver somniferum. Based on the source, we are also giving the name of the heterocyclic. Okay, we leave the nomenclature, but it is not serious. Most of the time it is called by the name of source or by the name of heterocyclic present. Okay, right. Next, coming to structure determination, general methods of structure determination of alkylides. It is very important. General methods of structure determination. In previous chapter also, in the alkylide, terpenes and terpenoids, we are also discussed about the structure determination of alpha terpenol, leminone, camphor. In these cases, we are applying several methods. Here also, for the determination of structure for alkylide, we need to apply some methods. For applying those methods, we need to know, or we need to familiarize about the methods. Okay, those methods are known as general methods for structure determination of alkalides. Right? In that, for example, you have an unknown compound. For knowing its structure, we need to follow some steps. The first one is determination of physical constant. And second one is determine the molecular formula, that is elemental analysis, and identification of presence of unsaturation, and type of and nature of functional group presenting. Suppose in the molecular formula oxygen is there. Oxygen is present in that molecule in what kind of functional group, and if it is nitrogen is there, what kind of nitrogen functional group is present in it. And also we need to determine the detection of type of and size of the rings. What is the type of it? Is a heterocyclic ring or a carbocyclic ring, or what is its size? Size means it is a 6-member ring or 5-member ring or 3-member ring. You need to determine. And also for identifying the positions of the side chains and position of heteroatoms and position of functional group, we need to perform some chemical degradation experiment. What is the degradation experiment? Degradation is the process to degrade the molecule or divide the molecule into smaller fragments. That is known as chemical degradation. We are using the chemical reagent for breaking the molecule into smaller fragments. Those methods are known as chemical degradation. These chemical degradations are important to identify the parts of the molecule or identify the structure of the parts of the molecule or entire structure of the molecule. Later, after identifying the complete structure of the natural product, we need to confirm it by the synthesis. After synthesizing that molecule, we compare the known one, isolated one, and the synthesized one. Whether those two are same, therefore the compound isolated from the natural source, we identify the structure. The structure is same with the synthesized one. Therefore, the structure is confirmed. If the synthesized structure and isolated structures are different, then we need to revise the structure elucidation method or structure determination steps by which we can confirm the structure. Okay, these are the 7 steps we need to follow for determining the structure of alkalides. For determining the alkalides. Now, first coming to determination of physical constant. I am coming to determination of physical constant. Physical constants means, suppose you take water. The same water can boil at 100 degrees at India or anywhere else in the world, right? The same time, the water freezes at 0 degrees. That is between the -4 to -4. Therefore, the temperature is the melting and boiling point of a component will not change. If it is a pure compound, whether it is the water or any other compound, whether it may be inorganic compound or a heterocyclic organic compound or general organic compound, their melting and boiling points will not change. Therefore, these melting points and boiling points are the fingerprints for the compounds. Once you determine these are the constant, based on that these constant values, once we are isolated the alkali from the natural sources, we need to determine the, if it is a solid, you need to determine the melting point. If it is a liquid, you need to determine the boiling point. These constant values you need to compare with the literature. Once you compare the literature, it may be matched with the known one. If it is not matched to any one of that compound, it may be a new compound by which we can identify the alkalides based on the melting point, boiling point. Therefore, we need to determine the physical. These are the physical constant. Based on the physical constant data, we can identify that so alkaloid is isolated from the natural source. Or if it is not doesn't match with the reported one or literature, therefore it may be a new compound. We treat it as a new compound. And third one is the optical activity. Optical activity is the phenomenon. We need to determine the optical rotation of the component. When you are going to determine the optical rotation, whether it is the stereo, that means optically active stereoisomer only can give the optical activity. That is enantiomer or whether it is a diastereomer or enantiomer, it is having a chiral center. That chiral center can show the optical rotation. Then we need to determine that optical rotation. Once it rotates the plane polarized light in the polar emitter, that is optically active. You need to determine the optical rotation. This optical rotation is also important to identify the compound from the natural source. Okay, this is the first one. That is, these physical constants will not give the complete evidence of the alkali structure or natural compound structure, but it gives the basic and fundamental information about the compound. Right. Next, elemental analysis. Elemental analysis means we need to determine the composition of elements of the isolated compound. That means the percentage of carbon, the percentage of hydrogen, percentage of nitrogen, percentage of oxygen, or percentage of sulfur. Determination is called as elemental analysis. There is a elemental analysis equipment is there, CNS analyzer, in which we are going to insert the sample, from which we can give the percentages of carbon, hydrogen, and nitrogen, by which we can calculate the oxygen and other halogen and sulfur quantity present in it. Okay, or other methods. The traditional molecular formula determination method. The molecular formula determination method means traditional method, that is the colligative properties method, that is by using the elevation boiling point, diffusion and freezing point, by which we can also determine the molecular weight of the compound, from which we can quantify the molecular formula. And the second method, spectroscopic method. Spectroscopic method is the key method, and that is the effortless method, because it is once you isolated the compound, you submit the sample to the spectroscopy department. They are analyze the compound, give the molecular formula and molecular fragments present in it. But that is the mass spectroscopic analysis. The mass spectrum is the very powerful tool to identify the molecular formula, and several important fragments present in it can be easily identified by using this method. Right. Next. High resolution, the mass spectroscopic method, high resolution HRMS is the very important and powerful method to determine the exact composition of the elements present in it. Next, presence of unsaturated bonds. Unsaturation means Suppose the compound is existing with a single bond, CC single bond, only sigma bond. That is the fully saturated one. Suppose the compound is existing with a double bond, C double bond C or C double bond C triple bond C. Such compounds are known as unsaturated compounds. Alkalides with most of the compound alkalides are existing in nature as unsaturation. Therefore, this unsaturation can be identified by utilized by using the reducing reagents and addition reactions. Here we are using a reduction or catalytic hydrogenation reaction in presence of nickel or any other catalyst. We can reduce it, that unsaturated compound into saturated. Similarly, we can also add them. We can also treat the alkaloid with bromine like addition reagent that leads to formation of addition product. Suppose if we are adding bromine, that gives the bromo product. Suppose the alkaloid is having one double bond. We are already previously seen in the alkaloid terpenes and terpenoid during the structure determination of alpha terpenol and laminone. We are adding the bromine. Well, if it is having one double bond, we are adding one molecule of bromine that leads to formation of dibromo product. If it is having two unsaturated bonds, that is two double bonds are there, or one triple bond is there, it leads to formation of tetrabromo product. Okay, that is the bromine addition takes place. It leads to the bromo product that indicates the presence of unsaturation in the alkaloid. Next, this is the example. This is a prostaglandin 1 PGE1. In that we are treating this catalytic hydrogenation. Just a minute. Yeah, this is the catalytic hydrogenation. It undergoes the catalytic hydrogenation. It leads there is a double bond is there. This double bond will be hydrogenated. Therefore, two hydrogens are added at these two positions. That leads to the formation of saturated bond. Therefore, this is called dihydro PGE1. Suppose one double bond is there, it leads to the formation of dihydro PGE1. Two double bonds are there, tetrahydro. Three double bonds are there, that is hexahydro PGE1. Similarly, if it is the same product, PG1 is treated with the bromination, that is the formation of dibromo product. In the PGE2, two double bonds are there. Okay, two bromine molecules are undergoing the addition, that leads to the formation of tetrabromo. PGE3, three double bonds are there. It leads to the formation of hexabromo. PGE1 derivative will be generated. Okay, this is the example for the identification of unsaturation in the alkalides. Okay, it is not alkaloid, it is a prostaglandin one. It is one kind of natural product isolated from the bile duct of the human or other animals. Right. Type and nature of functional groups. We know that once we are identify the molecular formula of the compound, molecular formula gives the information that what kind of elements present in it. That is, the carbon, hydrogen is generally present in the organic compound, along with nitrogen is also present. It is alkaline, but other elements like oxygen, sulfur is there. If the oxygen is there, oxygen may exist in the form of alcohols, OH groups, or in the form of phenolic form, or in the form of acids, carboxylic acids, or in the form of aldehyde, or in the form of ketone, or is in the form of esters, like that. Suppose sometimes this nitrogen group may also exist in the form of nitro, amino, amido in functional groups. Okay. Suppose sulfur is there, the thiol, mercapto functional groups may exist in the form of mercapto functional group. Okay. By analyzing that alkaloid structure, we can find out that the molecular formula. By using that molecular formula, we can find out the type of functional group present in it based on the element present in it. Okay, identification of nature of oxygen. So here the time is over. The next class maybe starts at 1 o'clock, I think. Okay, 1:30, I think. Okay, you take the lunch break. Physical class will start at 1:30. You join into the physical class. Later at the 3 o'clock, again organic class will be repeat. General chemistry class will be organized in the middle of the week. That may be Wednesday or Tuesday evening after 6. Okay. Now I am closing the session. Again, I will meet you at 3 o'clock. Thank you.